You not here yet. Morning. The phenomenon in your class. Yes. Okay. Before we start, any question from last lecture or tutorial you did? Yeah. Hi. You want to ask now? Sure. Yeah. 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 Hello, ask. Yeah, you can ask now. Yeah. Oh no. No question. Okay. Anyone have question from lecture or tutorial? Have you guys tried the review question yet? For chapters? Review question? Not yet. No time. Please, please arrange time to do exercise. What's the discussion at the back? What's the discussion? Any discussion? Huh? Okay, so maybe let's start. Okay, everyone. You can see that the sun is quite red, so please drink more water. Are we guys ready yet? Hello, hello, hello. The back. What's going on? Done? Ready? Ready? Okay. So I posed this question here. I'm not demand any question for any answer for you, but you can think about it. Because I want to bring out another thing. Does everyone have a read on this question already? Everyone got this question? Okay. Okay. So everyone read this, and you can read this and think about it. Okay, because I want to bring out another thing. Okay. So typically, I think students do maths. I think kind of boring. Okay, just play around with number, algebra. Okay, maybe draw some diagram. Doesn't make sense to you even. Okay, so you just think that this try to make sense. So um, so before long time before, how they do maths is a little bit different. Okay, so we have two part. Okay, so this is the quite two important themes in our course, right? So let me give you some context. Okay, let me give you some context how we do these maths. Okay, so that you feel that you are in a part of the history. Okay. Ah, okay. Okay. So so what we do about this circle, triangle, parallel, okay, parallel line. Right. Okay, just very short, just very short. Okay, keep it short, short prelude. So, these are the time when these Babylonian and Greek, okay, do this geometry, parallel line, triangle, circle, and you could see that we use 1, 2, 3, 4, 5, right? So, for example, 3, 4. These are all Arabic. Okay, so the time algebra gone very mature during Arabic time and Indian time. Okay, for example, you use XY, okay, XY 3, 4, 5, 6. These are our Arabic number. XY are alphabet. So when these two get married together, okay, when they get married, we get something called the analytic geometry. We don't call it algebraic geometry. Algebraic geometry is something else. So we call it analytic geometry. So how does analytic geometry come from? Remember when we start the class, right? We talk about Cartesian coordinate. Yeah, we talk about Cartesian coordinate. So what's this Cartesian from? Okay, so Cartesian come from a name of a mathematician or philosopher, French philosopher, which is René Descartes. Okay, so he married, maybe with Fermat, he married this algebra and geometry together. So meaning we place this geometry on top of some coordinate axis. Okay, that's why now when we draw surface, draw circle, we start with this coordinate axis. We start with the equation. Okay, then we have this geometry. Okay, so René Descartes is a philosopher. So there's one famous phrase he's about. I think, therefore I am. Okay, so some of you just snooze. Okay, I think, therefore I am. So I think, okay, so there's one famous phrase he say, I think, therefore I am. Okay, so what does this phrase mean? So this phrase go back to the first question we asked. So suppose non-physical thing can define you. How do you define your existence? How you find you exist? It's because you doubt that you exist, then you exist. Okay. So I think, therefore I am. So please think. Okay, please think. Every time doubt. Yeah, doubt me. Okay, whether what I say is true or not. Doubt. Okay, yeah. Okay, doubt. Okay. Only when you start doubting, you start learning. Otherwise, you are just a robot. Okay. Okay. So next, so we got exercise today. So let's do some tutorial question. Well, tutorial question today before we start new material. Okay. So first one, let's find the area bounded by r equals to 1 plus cos theta and r equal to 1 minus cos theta. Okay, let's work this out. Everyone see it? Find the area bounded by these two algebraic equations. So I let you think a little bit. What does this mean? And then what does this two equation mean? Let me check if I copy the right question. And try find find the bounded area bounded by these two curves. Okay. So if you haven't do any exercise yet, so this is a good place to start. Anyone remember what name called by this polar curve? What's the name? Yeah, this curve have name. Huh? Cardioid. Cardioid. Another name? What? Yeah, limason. Okay, the snail. Yeah, let you try for 2 more minutes and then we'll discuss. Yeah, just try. Okay, try whatever you can. Try find the for those who just came in. Try find the area bounded by these two curves. Anyone done yet? About 10 minutes past. Should we start? Discuss. Should we start? Okay, so let's start. So you want to try and find the area bounded by two polar graph. Okay, so where to start with this polar graph? Yeah, how to plot r equals to 1 plus cos theta and r equals to 1 minus cos theta. Okay, when to start? Okay, so we should start from a basic curve first. Okay, so what's the basic curve you know? Y equal to cos x. Okay, so you know about sorry, you know about y equals to cos x. So let's start with r equals to cos theta. So r equals to cos theta is the starting point. Okay, so we start with r equals to cos theta. So you should know how to plot r equal to cos theta, where the intersection here is 1, and then the other side we've got -1. So the whole graph is bounded by 1 and -1. And then what are these? So there are 4 crucial points you need to know, okay, for the x-axis. So you should know that cutting the graph into half, you got pi, okay, and then this graph is running from 0 to 2 pi, okay, and then cutting further half, you got pi over 2 on the left, and then 3 pi over 2 on the right, okay. So these are 1, 2, 3, 4, 5, 6. So 6 points you need to know about this r equal to cos theta graph, okay. So whenever people talk about this r equal to cos theta, you should be able to draw this. Okay, but this question asks about 1 plus cos theta and 1 minus cos theta. So what does this number do to this basic graph? Okay, let's talk about r equals to 1 plus cos theta. Okay, so what does 1 plus cos theta means? So it means that for every theta, you add 1. Okay, which means what? You translate the whole curve by 1 out. Okay, so meaning -1 here become 0. Okay, and then 1 become 2. Okay, 0 become 1. Make sense? Okay, so we will draw this graph out. So the shape is still the same. You just shift every point up. Okay, you still got the same shape. Okay, so now 1 become 2. -1 becomes 0. Okay, and then you are somewhere in the middle is 1. Okay, similarly, you can plot these 4 point out where you have pi over 2 pi, 3 pi over 2, 2 pi. Okay, so the shape still the same, period still the same. How about 1 minus cos theta? Okay, so first you need to consider what does minus do to the basic curve first. So what does minus do to the basic curve? 1 become -1. Okay. 0 still remain 0. Okay. So minus the basic curve, invert the curve around the x-axis. So really before that, I need to draw something like this. Okay. So positive become negative, negative become positive. Okay. So you invert the basic curve. Okay. And then 1 plus minus curve cos theta. So you shift everything up again. Okay. You shift everything out by 1. Is everyone following? Okay. So what you got is an inverted cos theta starting at 0. Similarly, you can plot these 4 curve out, 4 point out. Okay, so these are just Cartesian coordinate, okay, in r theta plane. Now we want to change it to a polar graph, okay. Polar graph work on xy coordinate, okay. So you need to change these curve into xy coordinate. SY plane, I mean. So let's add another. Please remember that these steps are the same for every polar graph you need to plot. So these are, I will put SY here to remind you we are on the SY plane. Okay, on SY plane, what's the polar coordinate? Okay, what's the polar coordinate? So the polar axis look like this. Okay, so this is the radius. And then the theta go counterclockwise. Okay, so radius growing up from the origin, and then angle work from 0 from the x-axis, positive x-axis, and then going counterclockwise. Okay, so these are the two axes for the polar coordinate in xy plane. Okay, so so the key question here, so this is the key of this course. So how to translate this r theta plane curve into a polar curve in SY plane. So you need to read this coordinate. Okay, read the coordinate on r theta. So what's the coordinate for this? The theta is 0 and then the radius is 2. Okay, but usually we will put r theta like this instead of theta r. This is just a convention. Okay, so let's say 2, 0. Radius is 2, theta is 0. Okay, so where is it on this xy plane? Where is this on this xy plane? If r theta equals 0, where is it on xy plane? It is radius 2 from the origin, okay, and then degree 0. Okay, degree 0 lie on the positive x-axis. Okay, so here is your, let's say here is 2. Okay, so this is your 2, 0. Okay, so in this xy plane, right, there are also 4 points you need to take care. Okay, so let's say we start with 0 degree here. Okay, we put radian. To the middle vertical here, what's the radian? It is pi over 2. Okay, if you go around counterclockwise, you will meet pi and then 3 pi over 2. Okay, pretty much these 4 points will determine how the shape looks like. Okay, so you need to know that what happened to your polar graph at 0, at pi over 2, at pi, at 3 pi over 2. Okay. So for pi over 2, what's the point in r equals to 1 plus cos theta? 1, right? Okay, so the radius is 1. So meaning you will meet another point at 1. Okay, so you will meet another point at 1. How about pi? What's the radius at pi? 0. Okay, so you will meet 0 here. How about at 3 pi over 2? 1. Okay, 1 again. So you have radius 1 here. We got a minus here because the other direction. Okay, so you should note that minus 1, 3 pi over 2. Let me see. 2. Should I say more? Maybe I let you ask. Okay, I don't want to say more first. I let you ask. Okay, I don't want to say more. Okay, so we have 1 on 3 pi over 2. Okay, so how to join these point together? Okay, how to join these point together? So we see that minus 2 here, decrease, 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 decrease when you have theta increase up to 1. Okay, so meaning when the angle increase, the radius decrease. Okay, so you join 2 to 1. Okay, maybe I make it higher a bit so that it look more nicer. Okay, so I go really slow, so please follow. I know that you go back, maybe you don't want to do exercise really. So please follow this exercise. Okay, this exercise will help to save your life. Okay, save your life. Okay, so next, what happened? So when you go from pi over 2 to pi, okay, what happened? The radius still decreasing from 1 until you diminish at pi. You get 0. Okay, so you have 1. Okay, so you have 1, and then you decrease, 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 decrease up to 0. Okay, so you slowly go into 0. Okay, what's next? So you can see that there's symmetry here. Okay, so basically you do the reverse thing. So you from pi to 3 pi over 2, you increase, increase, increase up to 1. Okay, so you increase, increase, increase up to 1. And then you keep increasing again up to 2. Okay, so that's why we call this a cardio. So it looks like a heart. Okay, make sense? Okay, let's do one more exercise on the right. Okay, let's plot r equals to 1 minus cos theta. So similarly, 4 point you need to take care. Okay, 0, pi over 2, pi, and 3 pi over 2. So ask yourself, when the degree is 0, where's radius? Where's the radius? Okay, in this case, where's the radius in this graph? When it is degree 0. 0. Okay, so you start with the origin. How about pi over 2? Huh? 1. Okay, so we got 1. How about 3 pi first? What's pi? What's the radius at pi? 2. What's the radius at 3 pi over 2? 1. Okay. Why we put a negative here? Because of the xy plane. Okay, but it is really just one radius from the origin downward. Okay, downward. Minus is just a sign. Okay. Okay, so we got these 4 points here. So what do we do? Where we start? We start with degree 0. Degree 0, the radius increase up to 1. Okay, so you will see that this point here, when you go away from this degree, you have increasing radius. Okay, until you increase to 1. Increase to 1. Okay, and then what happened from pi over 2 to pi? The radius increase again, increase up to 2. So you increase, 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 increase up to 2. Okay, so similarly, you can see that the symmetry here. Okay, basically you do reverse thing after pi. Okay, so after pi to 3 pi over 2, you decrease from radius 2 up to 1. Okay, so you decrease up to 1. Hey, hello, 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 hello. Hey, 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 hey. What's discussion? Okay, so next, 3 pi over 2 to 2 pi. Okay, so you decrease again up to 0. Actually, this graph go on and on, on. Okay, so basically you can repeat the process, and you can see that you are keep repeating this shape. Okay, then that means you are done. Okay, once the shape is keep repeating, this is the whole curve, whole graph you get. Any question? Any question? Huh? Why got discussion? Got the question? Yeah, go question, then we can address. Okay, so now the question asks, find the area bounded by these two curves. Okay, so bound these two curves. Okay, so we need to put these two curves together. Okay, so let's put these two curves together. Okay, so I put these two curves. Okay, maybe let me change the color so that it's easier to see. This color to this. Okay, so let's see how they bound each other. What region are bounded? Okay, so you can see that where is bounded? Where is bounded? Which region? So they are like they bound about 1, 2, 3, 4. Right? Okay. So if the region bounded by both of them should be somewhere in between, right? So this is what we are interested in. Okay, bounded by both. Okay. So have anyone already worked until this stage here? Anyone up? You okay? So how do you find the area? Can you share to us? Like me? Okay, how you set out your integral? Have you set out your integral yet? How do you set out your integral? Four times 1/2. Well, okay. Four. Oh, okay. I mean, outside inside should be the same. Yep. 5/2 to pi. Okay. Hey, please listen to what your friends say. 1 plus lambda square d theta. That's all. Okay. So why you pick this? Why is it 4 times? Where's the number 4 popping up from this area? Okay, you think that it is symmetric. Okay. Okay. So symmetric on which axis? Y axis? I guess someone assisted. Second quadrant. Yeah. So you compute this part. So you compute so you break this area into 4 parts. Very hard to see. So That's white. White, orange. Okay, so says that you can break this area into 4 parts. Okay, the white and the orange part. Okay, it seems that there's a symmetry on this area. Okay, but you please be careful when you use symmetry. Okay, please be careful. Okay, when you want to use symmetry, right, make sure that how the curve make sure that you know how the curve. You get what I mean? What's the gradient? What's the gradient? How does the curve change? Okay. So for example, I just give you an example. Okay. So let's say one of the part is more, is less curved. Okay. Then you won't have this 4 symmetry. You only have 2 symmetry. You know what I mean? So they don't split into 4. Okay, so make sure you know that how that curve is the same. Okay, how these two graph curve here, how they change, how the gradient change is the same. Okay, only that you can measure the symmetry. Okay, and then what else? Okay, so he picked pi over 2 to pi. Okay, let's say we have the 4 symmetry here. He picked integration domain from pi over 2 to pi. Can I pick 0 to pi over 2? Can I pick 0 to 2 pi over 2 or not? Yeah, can or not? Can, right? Because from 0 to pi over 2, I also get the same area, but with a different curve, right? So this part is the 1. Oh, okay, wait, this one should use 1 minus, right? If you want to put, this is a, let me see. Oh, okay, sorry. This is a 1 plus. Okay. So if you choose a different integration domain, then you should pick a different curve. Okay, because it's bounded by a different curve. Okay. Right. Because one of them is bounded by this pink curve, the other is bounded by the blue curve. Okay. Any question? 0. Oh, sorry. Yeah. 0 to pi over 2. Okay. So anyone who finish compute what this area is? Yeah. Yeah. Ask. 3 pi over 2 minus 4. Okay, good. Do you guys want to go through the integral or you can do the integral yourself? Anyone want to go through the integral? Anyone? Huh? I feel like doing it or not? I don't feel like doing it. But if you want to see, then I can show you. Huh? Don't want? Who want? Anyone want? You know? Do I? Okay. If you want, then I do. Yeah, do the right hand one or left hand one. Whatever. Okay, let's do the one I have answered. Let's do the right hand side one. So does anyone know where this one half come from? Yeah, formula. Okay, 1/2 is a formula, come from formula. Okay, let's do the right hand side one. So if you deal with this square function, right, it's good that you multiply them out so that you can integrate term by term, okay, because integration is linear. Okay, so there's something not good about this function here. You have power of integral, power of trigonometric function. Okay, so you need to make it back into a normal cost function with different period. Only you know how to integrate. Okay, so you need to use the trigger identity. Okay, there's one thing I want to remind you. So start doing a cheat sheet. Okay, do you get me? Start doing the cheat sheet. So write down whatever identities, whatever rule you need on one piece of paper. Okay, at most two-sided page A4 paper. Okay, let's say if we say exam, we can bring cheat sheet, then you bring that cheat sheet in. Okay, if not, then that cheat sheet will become a summary sheet for you to do revision. Okay, start doing the cheat sheet. Start doing cheat sheet. Because next week we're going, maybe this week or next week, we're going to another chapter with a lot of tests. So you need to list them out. Okay, so now when you do integral, formula, surface area, everything, write them down in a cheat sheet. Okay, so that every time when you do calculation, you take out that cheat sheet and then refer it. Yeah, cheat sheet. Okay, so let's continue. So what do we have for this trigger identity? Yeah, yes, that's right. Yeah. So we got this trigger identity here. Trigger identity where cos 2 theta equals to half time cos 2 theta. Okay. And then what do you do next? So you just combine all the like term. So you get all of them together, you will get 3 minus 4 cos theta plus cos 2 theta. Theta. Okay, so now you can do integral now, normal integral. So you just get 3 theta minus 4 sine theta plus half sine 2 theta. Okay, and then you get what you want. Any questions? Yeah, so how to analyze this question? So first, you need to know how to plot the polar graph. Second, you should see whether there are symmetry or not to help you ease your calculation. Okay. Third, you need to determine your integration domain. Okay, what function you want to integrate over. Fourth, you need to really do the integration. Okay. So you go back to your calculus mode. So first part is calculus 2, second part is calculus 1. Okay. Well, we spent about 1 hour discussing this. Any question? Okay, before we take a break, one more question I want to do. 3D. So because today we continue with 3D topic, right? So let's plot this space curve in 3D. Yeah, try to plot this space curve in 3D. Why is it a curve? Because there's only one variable. So it's a function from R to R3. Okay, so you can think of it as a real line. Okay, so how this real line run in R3? Okay, how this run in R3? Why is it a space curve? Because this is a function, and then all of them are continuous component function, so it's continuous. Any question? Sure. Like a spiral thread? Yeah. How does it spiral? Okay, let me bring out the 3D space. Let's. Yes, correct. So whenever you see sines and cosine, right, you should straight away see if there's a circle inside there. Okay, any circle equation is satisfied or not. Okay, so circle equation cosine sine, you need to take square only they follow the sine square plus y square equals to 1. Okay? So let's say we square them. Okay? Let's say we square them. See if they satisfy some ellipse or circle or anything like that. Okay, let's see what happens. So we take a square of them. We are just experimenting. So whenever you see this sine and cosine, right, you should straight away see if there's any circle or not. So the guess is some spiraling along y-axis. Okay. So let's see is this true. Okay. So if you want to do s squared plus z squared, so in this case z squared, what do we get? Square t. Okay, and then you can do factorization. Okay. So what is cos square t plus sine square t? Equal to 1. So this is also one of the trigo identity you want to keep inside your cheat sheet. Okay, so this is equal 1 trigo identity. Okay, so meaning that you have circle around x z plane. Okay, and then this t here. Okay, t can be any number, right? But we have orientation. Our t runs from negative to positive. Okay, negative to positive. Okay, so when t is 0, okay, when t is 0, s squared plus z squared is just a. Okay, let me write down what I meant. When t equals 0, what is s squared plus z squared equals 0? 0. Okay, why? Two positive number add together, you want to get 0. What are the two positive number you can do? Only 0. Okay. So only 0, 0 satisfy this equation. Okay. Let's say our t run to 1. Okay. What do we get? Sorry, 1 here. We get a circle. Okay. So t equals to 1, we get a circle. But not that not what? No. Okay, not that we have another variable here. Okay, y equals to t. Okay, y equals to t. So when you have this circle running, right? When you have this circle running, okay, so at the moment you should think about something like we have when t runs, when t runs, we have circle growing. The radius become greater, right? Okay, but at the same time, every point have different t. Okay? Every point has different t. So when you want to run into a circle, but you are moving forward in y. Okay. When you want to move in a circle motion, but you could keep moving forward in time. Okay. So that's why you get a spiral along y-axis. Does everyone following? Is everyone following? Does everyone follow? Okay. So at first, you know that you got circle increasing in radius, but this is continuous. Okay. Increasing in time. Okay. Increasing in time. So when you want to move in a circle motion, but you move forward in the y direction as well. Okay, see that this is increasing in y. Okay, so you got this particle spiraling along the y-axis. Okay. Okay, maybe later homing us again. Hey, how about t less than 0? Huh? T less than 0, how? Huh? Less than 0, how? Okay. No, possible. But it still satisfies the same equation. Okay, so when the t go in the negative direction, you also go in a positive direction, right? Is it right? Let me think. I think it's not right. No, I think it's not right. So it should go the other way. Yeah. So if you want to consider t greater than 0, okay, then it will run this way. Okay, so if t less than 0, then it runs this way. So let me draw it up. So let's draw it up. Which direction? Yeah. Depend on the. I mean, usually the t, usually if just talk about t, right, the t will run for the whole real line. Yeah. Forgot lah. So what? Forgot the room. Yeah. Okay. Any question? Yeah. Why it become bigger? Why become bigger? Yeah. Here. Yeah. So the circle follow the t. Any question? Got. Okay. Any other question? I mean, real question regarding. Any other question? Technical question. Any one of you have idea what this looks like? Let's say just look at one of this. Sound wave. Okay, maybe sound wave. Physical stuff. Physical objects. Anything look like this that you have seen before in real life? Physical stuff. Huh? Oh, you mean the what's the seashell? Okay, seashell maybe. But what I think of is when you go to the temple, right? They put on the top and they burn it. Yeah. Okay. Okay, let's take a break and then we will start new stuff today. So take until 9:14. 14. 1:4. Not quite. Okay, let me see.
我是在这会儿是不是要是不是要给
就是像上次说，就是每一次我们每次一看这种题目，在这个课的设定，就是我们就是会看它在 paragraph， 就是这堂课这堂课设定，
所以整个课的
就是它设定就是这样，你一看到这个就是 paragraph。
因为是我首先就先入为主，还是把它
对
那个 tradition，然后就
你可以这么想，但是问题是这一堂课设定就是直接就是所以我们就不会一直在重复说啊，你一定要回去看那个，因为我们课设定就是这样。但是你在你的 top process 的时候，你可以从那里开始。
对，就是它这是分上的话，的面积是无穷大的，就跟这个一样的大。
好像被 cancel 掉对吗？ 像 cancel 掉，上面是加，下面是减。
那乘的是 n 点 area 不是永远是正的。
area 其实我有一个东西没有教在这堂课，就是其实那个 area 是有 orientation 的。是有 orientation 的，跟着你的 curve 有 orientation 的，就是说，我跟你说嘞，这是额外的东西啦。就是通常我们给你们算的 area 都是 orientation 是对的，就是说算出来的 area 一定是 positive。
对啊，那是
还有 orientation 的问题。如果你要看的话，你可以看我给你们的那个 A 的那本有提到。
对，它如是
但是如果是 above 的话，就是 positive 线
对啊，
对 positive 呀，上面的话是
对，然后它的这个例子它的
对
所以答这个是不一样的。所以说我们不是按 polar curve 来。
但是有一个很有趣的东西啊，因为我刚那个题目，我是感觉我不了解。刚有问题在哪？如果我们做一个比对呢，我们都可以就是大幅减小，你的还是
OK，没有错。
是为什么它不 applicable？还是其实我是 applicable 的。
所以你要大个减小个，所以你要找大个减小个。这边你先看一下有没有可以大个减小个呢？你要大个减小个啊。
因为 suppose 来讲，我们如果做 interpretation，只要有两个在一起。
没有，这个没有大个减小个啊，这个只是说这个没有教你大个减小个，大个减小个是其中一个方法，找吧。它这个的意思是说，只要你有一个 curve，你要找它下面的那个 area，就是这个东西。OK，所以你怎样用这个想法放到这边来，对不对？所以你看啊，假设不要看全部啦，看一个就好了。OK， 看一个就好了。我要找这里的 curve 怎样找 ？OK， 我就从这里 integrate 到这里咯。我要找这里要怎么找呢 ？integrate 这里到这里咯，这里呢？这里到这里咯，这里到这里。所以我们有4个 integration domain 可以拆掉。如果我们 integrate 整个的话，就是全部了咯。OK， 所以现在我们要 integrate 是这一个东西哦。OK， 先知道一下我们要 integrate 这个东西，所以这个东西能不能够把它拆成这样子的部分？先问这个问题。我们不是一开始就来大个减小个，我们一开始要先知道它是 under 什么 curve 先。
我还是要画出来。有没有一种 method 好？我们要找的是它的 area 在一起的是吗？这是 area 是什么？它是对呢。这个其实是什么东西来的？我要找的是
什么东西？
它的找它的 area，
对，
它们 integrate 在一起还是？
没有，就是说我要找 area bounded by 2个的，对，2个被2个curve 包住的 area 我才算，就是意思说 OK， 所以其实你要回去回答那个我的问题先，我要找什么 area？ 为什么我找的是这2片 area？ 因为这2片 area 是一个 bound by， 就是同时 bound by 1加 cos theta， 一个是1减 cos theta。OK， 所以我要找这个，我要找的是这个。
有没有可能呢？如果我们图片这样子，可以让它就是倒转过来。如果它倒转过来的话，我的 border 就出现了。来像它这样子，我就从这边我就出现这边了。
哎呀妈！你要这样的话也不是不可以，可以的。怎么你要给你自己这样多功呢？
它可能更多功啊。然后我这个我还有很多丢的东西，就是如果
但是你这样子的话哦，这样你就要考虑一个问题了哦。这样是说，我转的时候我没有影响我的 integral， 你要处理这些问题哦。然后你转了过后，这2个的 graph 是不一样的东西啊，你 integrate 不一样的 function 了。
OK，
不一样吗？这个是应该是 sin 吧？这个我觉得啦，忘记了。我觉得这个是 sin 的sin theta 的 graph。对，为什么你转了过后，首先你要处理的问题是转了过后，他们2个是一样 integral。第二就是你转了过后是一样的 integral， 然后就你要处理转了过后是一样的 integral， 然后你要 integrate over 不同的 function， 是不是？通常我们会取这么复杂的东西，是当这个东西很难算的时候，但是问题是这个东西没有很难算，那么你要去到这样的地方。
我想问一下，就是 这个公式的
Yeah，
推导过程有讲过，
书里面有，
书里面有，
书
你没有讲是吧？
我没有讲，我没有讲，
那么这个
不重要
公式就
不会讲
不会错。没有这个公式的话，就是考试的话，就是
不会教你推的，
我知道，就是考试它大概考到什么程度？
就是可能我们会给你假设啦，最基本的就是我会给你这个，然后你换这些出来咯，
画这些出来。
换这些出来。然后你要知道这些标记是什么啊，我有做一个 summary chart 啊，记得吗？我有画一个 summary chart 啊，我感觉我没有放波拉进去，可以留了一个位置。对，我做了这个，可是我没有放这个进去。OK，我把这个放进去，然后你就 study 这个就可以了。
嗯，之后会放进去。
这个我已经放进去了，这个你看过？
这个
看过？
这个好像没看过。
OK，等下我跟大家说一下，然后我会把这个也加进去，
对，
所以你有 Polar 的 version 又有 XY 的 version，两个都有，就全部放在一个图里面。
也就是说它大概考察方式也就是跟
跟这些都是
跟这些一直差不多。
对，但是我觉得更重要是他们会用这个来去叫你去算那些东西啊，对不对？
就是
他们的表达是
你就是说要根据这个公式先把那个图形画出来，然后
类似这样，
再去算微积分是吗？
类似这样，类似，
谢谢。
所以重点是图啊，然后做 calculus。对啊，不是很重要，说它怎么来。你要看的话，在 A 的里面，不，在你们的那个课本里面。
哎，老师，
怎么？
问你啊，这个哦，
也，
这波形它也是spiral不是？
你可以找到一个 spiral 的东西在里面，然后
没有，我知道问题哦，我好像他懂问题啊，
对
他叫我们画，
对，
是非常，
这是surface，对，
所以，可是它有连到，如果它是 spiral 的话，它会有surface，
没有 surface，
可是这个为什么会有 surface？
因为这个考虑，因为因为这是考虑所有点符合这个 equation 的，但是我们没有考虑所有点符合这个 equation 啊，我们只有一条 T 在跑啊。但是如果你考虑所有的，可以讲考虑所有的，没有，你要调才可以，要调，你不能
仅限于 surface，
没有 equation 不一样，equation 不一样。一样，符合的 equation 一样，但是问题是谁 control 那个 variable？
个题啊，
就一个 T 吧，这边有，
这里没有，
这边有两个东西在 control，所以这两个都会变 ，x 跟 y 都会变，我们的变法。如果你要想成我们那个东西的话，可能你想 y 的部分是 T1，z 的部分是 T2，这样就可以。可以，因为它有两个 variable 在变，你才可以画出一个什么？他的意思就是说 R2去到 R3，所以你要把 R2的东西给它熬，然后放在 R3。刚才我们只有 R 的东西熬，你就要放在 R3。来，
我只是怕，如果以后上学那种分出来啊，OK 啊，我们懂三个点上面是因为这个搭过这个嘛，这个点这个是不是？然后我们这个 case 的话，其实还是左边，就是
左边解右边。
左边解右边是没有。
那个的话可以考虑，那个是你要 change 那个
x 和 y 嘛。
variable 你还要 change equation 啊，你要写成另外一个 form 啊。
我可以换就会讲，不会是这样子的。
什么？
我不会画这样，因为这样我不要考虑这样情况的话。就如果这样题目，我就做这个 method 就好。
又来 method， 然后我是想说，没有，你如果要那样子的话，你是 xy， 我现在是 angle
啊，对。
对，如果我要做你这个左右的话，我还要把那个 r theta 改成 xy 线才可以做。
这我知道的吧，就是那个题目不好的方法，是因为我的 xy 不是 direct xy，我是 from，就是我要用这个方法的话，如果这个方法优化的情况是只有我是直接是 xy 是吗？
对，而且有时候那个 integral 又难 solve 哦，还记得吗？我们上次不是有 solve 一题用3个方法，那个 xy 要超级难哦。我要开始了，等一下可以吗？等一下再来。 We will start soon. Please be ready. Please be ready. We will start soon. Why everyone discussing probability?
You want to have a see? You want to have a look?
Huh? Yeah, I was in the maths club. Yeah. Huh? Half. Yeah, half. No lah, I just go and DC only. Yeah, DC. No, they are playing game. Yeah, they are playing game. Okay. Did everyone see this summary slide or not? Does everyone see this? Okay. I will add the R theta equation in as well. Okay, so that when you do revision, you just look at one slide and then you can do revision. Take this note. Yeah, not sure yet. Not sure yet. Yeah. So just make one first. Make one for yourself. If we can bring the cheat sheet in, then you just bring the cheat sheet in. If cannot bring the cheat sheet, then the cheat sheet will become your revision sheet. Huh? Yeah, of course, anything. 2 pages, anything. I mean, I'm not sure how many pages, but now you can try and make it 2 pages first. Yeah. I mean, during my time, right? My time. I mean, not my time, my university. We in mathematics, we are allowed to bring 2 pages cheat sheet. 2 pages. 2 paper too much already. Yeah. 2 pages. No, 2 pages A4. Okay, 2 pages A4. But I can tell you, it's no use one. Yeah, no use one. We have to like think how to use the formula. Yeah. What do you mean? Tablet. Yeah. You must do it. I don't know whether we will provide or you do. I'm not sure yet. I provide. Okay. Can. See first. Okay. But still, you should keep a habit and then keep all the familiar trigger identity formula together. Okay. As a revision. As your own revision. We'll start. So, okay, my plan is like keep 1 week earlier because chapter 11, right? Hello. Start. Chapter 11 seems to be longer than 3 weeks. Okay, based on what I teach in the other class. So we should be ahead of the schedule. And also, if we are ahead of the schedule, you can first see the idea and then let the idea sink in before you have exam. Okay, and then we have more times we can do tutorial here before the exam. Yeah. Okay. Which one plan to have on week 6? Yes, week 6. I think that week is the what's the day? What's the public holiday? Labor Day. After Labor Day. After Labor Day. Yeah, after Labor Day. First 3 chapters will end with this. Yeah, end with this 10, 12, 13. End with this chapter. Huh? Yes. First 1, 3 chapter. So. Please do as decide. Don't wait until last minute. 3 quizzes. Yeah, don't wait until last minute. And then what else? Yeah. So basically, this chapter, right, as chapter 13, as expected by some of your friends, this is just repeating what we did in 2D. Okay. So you should remind yourself about 2D. Okay, when we do about 3D, 3-dimension. Yeah. It's just extension of 2-dimensional. Okay. So let's start. Any more question or not? Okay, if not, okay, we should start now. Okay, should we talk about the idea of derivative first? Hello, let's start. Start. Hey. Let's start. Right? Hang on. Yeah. Okay, so for gradient for a line, right, it's easy to find. Okay, so the gradient of a line is easy to find. So it's just y1 over y2 minus x1 over x2. I hope you can recall from your high school. Why can we do this? Because the ratio is the same no matter what 2 points you pick. Okay, this is a line. But things get hard when it is not a straight line. Okay, if the line is like curvy like this, what to do? Okay, what to do? How? Okay, like you cannot pick if you want to find a tangent on one point. Okay, there's no valid point on this which is on the curve, right? There's no point on the curve. It's not on the curve. Okay, if you want to pick this y1, y2, and then x1, x2, but this pair of points is not on the curve. Okay, yeah, not on the curve. How to find? Okay, what we do is we draw infinitely many curves that is close to this line. Okay. And then you will see that this curve will converge to the line that we want. Okay. That's why we take a limit. So let's call this S naught, Y naught. So we take a limit from X naught, Y naught plus, sorry, my sound of it off. Yeah, the weather is too hot. Okay. So what does this mean is we care about the point a little bit away from the point that we want to find. And then we take the limit of fx naught y naught minus fx naught plus h x y naught plus h over h. And then we actually should use, yeah, let's stop here. So this is our m. Okay. So this is the limit we mean. So whenever we talk about limit, there's infinitely things coming out. So where's the infinite thing? So this is all these line here. Oh, these are all these line. Okay, this is the infinite thing you consider. Okay, so we can do this for vector as well. Okay, so now we do it for vector. So we also take limit of something away from our vector that we want to find, the point that we want to find, and then divided by the change. Okay, although this definition doesn't really matter for calculation, but I want you to have some context. Okay. So really dy dt coming from limit. Okay, coming from limit. So which they call this first principle of derivation. So every time you see dy dx d, okay, let me write down. So every time you see like d dx of x squared equals to 2x, you just think that take the power down and then minus 1. Actually, this is not how dy dx come from. Okay, dy dx come from the limit. Okay, when you do all the limit calculation, take limit, maybe you need L'Hopital or whatever you want to use, then you get 2x. Okay, so this is really a surprising result where you can just see that d differentiate x squared, you get 2x, and then differentiate other power also become reducing the power. This is the surprising result. Okay, but the hard part is the definition, the limit definition. Okay. So what you learn is after process, after being processed, what you learn. Okay, I mean in high school. Okay, next. What's next one? Okay, next is so let's talk about this. So next is let's talk about this theorem first. Okay, so the key part is this theorem here. So if you have a vector function, okay, remember what's a vector function? So it's a function from R to R3. Okay, in our course we start at R3. You can do Rn. Okay, let me write out what I mean. So we go from R to R3. Okay, and then we have T, and then this T control 3 coordinates. So you got 3 component function. Okay, so how to differentiate f prime? Okay, so how you differentiate f prime is exactly you differentiate every component. Okay, so another way to think about this f, right? You can think of it as f equals to f1, f2, f3. Okay, where f1, f2, f3 are going from R to R. So you got 3 of them. So make into R3. Okay. So I equals to 1, 2, 3, all of them. Okay. Because you know how to do differentiation on R to R, right? Okay, so you can differentiate every term. Maybe I don't want to go into this unit tangent. Unit tangent is just divide the tangent vector by the length. Huh? I don't mean don't exam. I mean there's nothing much to say about this. So I mean, okay. So unit tangent just means a tangent vector with a length 1. So you divide your tangent vector by its length. Okay. This is not so important for now, but length. Okay. Okay. So let's try what we have said. So let's try an example. So we have this vector function here. Okay. So how to differentiate RT? How to differentiate RT? So we start with what I. Okay. So okay, actually there's another defect on this notation here. There's a defect on this notation. When I put prime here, right, I differentiate with respect to what? T. Okay. In this case, is obvious. There's only one variable, so which is t. So we differentiate with respect to t. Okay. So if you really want to do this, maybe you start with the first principle, but the theorem says that we can just differentiate component by component. Okay, so we bring the prime into our component function. Okay, so let me ask a question. Is it crazy that I put a prime on 2? Crazy, right? Why can I put a prime on 2? Huh? What do you mean by 0? Okay, because you see 2 as a constant function. Okay, so it's not a number. 2 is a function now. Okay, 2 is a function. It's not a number. So you put on the constant function. Okay, constant function, which is zt equals to 2. So this is a function. So I can differentiate the constant function. Okay, you are not differentiating a number. Cannot differentiate number. You need to differentiate function. Okay, function. So here is constant function. Okay, I think you are very good in differentiation, right? So what's the I component you get? 2t plus 1. J component. Et again. Okay, so no matter how you differentiate et, you get et. K 0. Good. Check it. Okay, so you can see that after differentiating this curve, the z component go away. Okay, only left with 2-dimensional. Okay, let's compute one more. R prime prime. Keep continue differentiating. ETJ. Okay, so what's the I component? Okay, this one become 1. Okay, 2i. J become ET again. Okay, good. So next, find the angle between R prime 0 and R prime prime 0. Okay. Okay, so angle between two vectors. So first, let us determine what's the vector first. Okay, what is what R prime 0? What's the vector R prime 0? I plus J. Good. What is R prime prime 0? 2i plus J. Good. Okay. These two vectors should be easy. I mean, easy to see, right? I mean, this is 1, 1 and 2, 1. Okay. Now the question is find the angle between these two vectors. So I get, okay, let me pass this angle to this. So I get some feedback from you guys say that what is dot product? What is cross product? Okay, so let's revision again. What is dot product? What does dot product give you? If you dot two vectors together, what do you get? You get a number. Okay, when you cross two vector together, what do you get? A vector. Okay. So what about these two number and vector? Okay, let me do some revision. I go relatively fast last time because I assume you learn in the algebra. Okay, so this one get a number. This one get a vector. Okay, any n. Maybe stick with R3 because you guys kept at R3. So okay, so you should ask the question, what is the significance of this number and vector? Okay, what's the significance of this number and vector? Okay, what does this number give me? So A dot B, I get one number, 5. What does this 5 mean? Okay, what does this 5 mean? Okay, so we got a formula. Okay, we got a theorem which says that A dot B equals to the length of A times length of B cos theta. Okay, so this 5 split into 3 parts. Length of A, length of B, and the angle between them. Okay, so if A and B are given, these are known. Okay, the length of A and B are known if AB given. Okay, then you can find what's the angle between them. Make sense? Okay, so this number can give you angle between A and B if A and B are known. Okay. Okay, dot product. Okay, everyone, get the angle between the two vectors. How about cross product? What does this vectors tells you? Perpendicular to the both vectors. So which means A cross B dot N is 0. Sorry, I should say A dot B. Sorry, I should say A dot N is 0. B dot N is also 0. Okay. So there's no condition on AB. AB doesn't need to start with perpendicular. No need. Okay. Any two. Okay. Any two. Maybe you ask, how about A equals to A? A cross A, what do you get? Huh? You get 0. Okay. So A cross A, you get 0. If A and B start to be different, then you will get another non-trivial vector. Okay, so this is how we get the equation of plane, right? Because plane is all the points that are perpendicular to one normal vector. Okay. Any question on cross dot? Okay, if not, let's come back to this question again. So they want to find angle between two vectors. So use cross or use dot? Dot. Okay. Actually, there's one thing I don't tell you lah. Cross also can find angle, but dot is easier. Okay, I leave you to think how to use cross to find the angle. So let's use dot. No, it's important. It's important. Okay. So so let's use dot. Okay. So by theorem, what do we have? Okay, by theorem we have that r prime 0 dot r prime prime 0. We got the length of r prime 0 times r prime prime 0 times cos theta. Okay. So okay. So there's a few computation to do here. One dot with 2, 1. Anyone still remember how to find the length? What's the formula of the length? Square root of the inner product, which is the dot product. Okay. Inner product, which is the dot product. So you dot them together. So you dot yourself. And let's put double line to be consistent. You are right. You're right. So you're right. So wait, let me put this guy. Yeah, I don't want to use this. We want to be consistent a bit. So does anyone have problems switching between IJK, row, column, row vector, column vector? Anyone have problems switching between these notation or not? Anyone have problem switching between these notation? Cos theta. Okay, so what do you get? You get 2 plus 1 on this side over square root 2 over square root 4 plus 1, 5 cos theta. So theta is just cos inverse of 3 over square root 10. Okay, I don't have this, I don't have calculator with me. You give, so, I mean, you calculate? Let me calculate. What's it? Radian. 0.10345. 10245. No place to write. 0.10345. Huh? Pi? Pi. Oh, pi. Just put radian. Just put radian. RAD. RAD. Pi. Why? Why in pi form? In radian form? Or you in pi? You see, in pi form very weird. Because you half or both are half. Because he need to multiply pi again. So you get what? What do you get? 0.3 to 1. 3 to 1 radian. The problem with giving decimal plus pi, if you are giving two half answer. I mean, not say you cannot, but it's better you write in full. I mean, if write one half, then just one half. So write radian, then stop at radian. Yeah. Don't both half. Yeah. Okay. Pi is an irrational number, so it cannot stop. The decimal place cannot stop. Okay. So, okay, remind again. So what do we do just now? So the tangent line to the curve has a direction vector r prime theta. Okay, so if you want to find tangent line to a curve, what is r prime theta? Is the direction of that tangent line. Okay. Yeah, let's do this question again. Find parametric equation for the tangent line to the helix with parametric equation the following, and then at the point 0, 1, pi over 2. Okay, so remember that we have this kind of question before, right? For R2, right? We find the horizontal tangent, vertical tangent, and then we find the equation of the tangent line. So now we do the same for R3. Okay, we do the same for R3. Let's do the same for R3. So, okay, so what do you do first if you want to find tangent line? Huh? What do you want to find? Huh? What do you want to find the tangent line? Differentiate the vector equation. Okay, so you need to write down the vector equation first. Now they give you the parametric form, right? So you need to write it into a vector equation. So what's the vector function you have? 2 cos t and at the I variable, sine t at the y coordinate, and then t at the z. Okay. So now you want to find tangent. So meaning you want to find the direction vector. Okay, note that you see, I changed my terminology already. Direction vector. Okay, that's why I introduced that line just now. So I changed my terminology here. Because now I want to think of that tangent line have a direction now. Okay, direction vector. So yeah. IJK. Yeah, IJK, correct. I mix up the two coordinates. I mean, IJK really is just a name. You can name it any way you like. But to be consistent, we keep IJK. Okay. So just now we already compute what is R prime T. We know how to compute, I mean. So we get minus 2 sine T cos T and then 1K. Okay. So what's next? We want to find tangent line at that point. Okay, but this R prime T, what does this equation give? This is a tangent line at any point T. Okay, we want to find it at 0, 1, pi over 2. So what's the T here? Pi over 2. Okay, we can straight away see from the Z coordinate. Okay, Z coordinate is equal to T. So Z coordinate already gives us what's the time. So the time is pi over 2. Okay, so at equals to pi over 2, what do we get? R prime pi over 2 is -2, 0, and 1. Okay, actually, right, just now, we don't need to write ijk inside our row vector again. Okay, because row vector use comma to differentiate already. Okay, no need to repeat twice. Okay, no need to repeat twice. Because comma help us to differentiate ijk already. So no need to repeat twice. Ijk. If you write in plus form, then you need ijk to differentiate which term is I, which term is j, which term is k. But if it is column form or column or row form, depend on the position, you will know what is ijk. So we have some convention in our mind already. Okay, next. So we want a vector equation. So tangent line or tangent line. What do you need for line? Point and vector. Now you got vector. So what's the point? 0, 1, pi over 2. Okay? Yeah, what's the point? So there are two. Okay. So where's the point 0? Okay. So how to put this together? So tangent line is, remember how to put this number together or not? How? L equals to P plus PT. Okay, good. So what is P now? Give the point. So the point is 0, 0, 1 pi over 2 plus the vector here is -2, 0, 1 t. Okay? But the question asks about what? Parametric. Okay, so parametric, you need to put it back as the x, y, z form. Okay, so they want parametric. This one is for vector. So you want parametric form. So parametric, how to write? X equal to -2 t, y equals to 1, z equals to pi over 2 plus t. Okay, so t runs from where to where? What? T run forever, okay, for a real line. Because you want to get a line, right? Yeah. Any question up to now? Okay. Can you see how we put all the things together now? Okay. We put everything together. That's why we split how you find line or tangent. Yeah, so what really we care is the tangent line. Okay, not just any line. Yeah. Zoom. Okay, it's okay. Zoom in. Which part you want to see? The final part? Final part. Everyone follow or not? Any question? Okay, let's do a bit more before we take another break. Okay, so far here, okay. Okay, next. Differentiation rules. Okay. So we know how to differentiate one function now. How to differentiate two or more function. Okay. So if you differentiate addition function, sum of function is just the same as you differentiate individually both of them and then you add them up or add minus them. Okay, respectively. How about if your function multiplied by a scalar? Okay, you can bring the scalar out first. Okay, so you can bring the scalar in or out before you differentiate. See which one is easier or see which one you have computed before. Which one is more convenient? Hey, when I see this, can you guys imagine or not? Cannot imagine. Okay. Okay, so let's see, you see, okay? So let's say you take these two function here, okay? So you can really, okay, let me remove this number. Really, what you do is you can differentiate. Okay, let me write it. Okay, let me zoom in more and then write it small. So let's say we got a two function, t plus t cubed, okay? So what you're doing is you just differentiate function by function and then add them all together. This is what you do, right? This is what you always do. Okay. Actually, this is not trivial. This is not trivial because if you just look at the left hand side, right, you actually need to go through the first principle first. Okay, you need to take limit. So why limit can split out like this? So limit actually also linear. Okay, when you take limit, yeah. Okay, so it is non-trivial. How about the second case? So if you want to differentiate 3t squared, for example, okay, you can do it as 3 times differentiate t squared. Okay, this is what it means. Okay, then we will continue. Continue the third one. Third one, a bit weird, right? Looks a bit weird. Why we got two functions here? What's the difference between two functions here? Both functions are in t. So why one both, why the other don't both? Okay, so you need to read the question here. F is a differentiable real valued function. Okay, so f is a function from R to R. Okay? But ut is a vector valued function, R to R cubed. Okay, so what it means is like something like e over dt differentiate on t times, for example, et 1 like this. Okay, so when you do this, right, you cannot just differentiate. Okay, you need to use the product rule. Then use product rule. Okay, this obey product rule. Okay, or you just multiply them in, it becomes a vector function, and then you differentiate component by component. And then actually what you do is also product rule. Yeah. This is the essence of this equation here. So how you go around, right? You still inside the same thing. Yeah. No matter how you see these faces, right? They are the same. Okay. What? Yeah, this is the essence of equal here. So this equal here are very important. Okay, next. Okay, next. How about differentiating a dot product? Okay. Maybe you will think, okay, let's think here. This one very important. You dot product, just now I say you get a number, right? How differentiate a number? It's a constant, okay? But see here. This number actually depend on t. Okay, so this one maybe is another function, is a real valued function. Okay, you might get something in t. So you differentiate a real valued function. Okay. So for here means you also can do product rule. Okay, product rule on dot product. Okay, using dot product. You can see that it also works for cross product. Okay, you also have something like product rule in cross product. Not that the multiplication here is different. One is dot, one is cross. Okay. The next part is chain rule. Okay, chain rule. The final part is chain rule. Okay. Yeah. Okay. It doesn't make sense until we see example. So let's do example. You can work out. Try and work out. I think you can find. Yeah. It's just component wise. Yeah, component wise. You can try and work it out. Actually, product rule is really Quotient rule is really a product rule. Hello? Quotient rule is a product rule. Yeah. Okay, I think the miss out one example, so let me write down this example. For example, let's try find the derivative of here. Should we do this? Okay, let's do this. Be undecided. Okay, let's say we want to differentiate this. Okay, I think we repeat ourselves again, but now we have more context. So we want to differentiate this. Okay, we are high class a bit. We don't want to put prime already. We put d over dt. Yeah. Actually, this question to change a bit. So let me change a bit. So we want to find d over dt of t cubed t. Okay, let's find this. So it is a real value function multiplied a vector value function. Okay, we want to do this. So one way is what we said just now. You just multiply the real value function into your component function, and then you differentiate function by function. But now we want to use this formula. Okay, we want to use this formula. So we're going to use formula 3. Okay, formula 3 here. Okay, we use formula 3. It's a big, if you want to memorize this, this is like the product rule. Okay, but they live in different category, those functions, but it's like product rule. So ft u prime plus f prime u, product rule. So this is equal to d dt d cube rt plus d dt minus d cube. Okay. So in this case, I hope should be easier. So we differentiate t squared t cube, we get 3t squared times rt. So what's rt? Rt is t squared plus t e minus t minus 2. Okay. Plus, okay, we want to differentiate the vector function. The theorem says that we need to differentiate component by component. So we differentiate component by component. We get 2t plus 1 minus e minus t minus 2 multiplied by t cubed. Okay. Anyone have question differentiating vector function? No, okay. So we just combine everything together. Get 3t. This is just basic. Okay, I shouldn't be that direct. Become yeah. Sorry. I'm not humane. Sometimes if you know things more, right, you become less humane. So you need to pull yourself back into human. Okay, next, just combine these two, right? Just add these two. So we get 5t to the power 4 plus 4t cubed. Okay, and then what else? This one we can combine, right? Factorize. Actually, the first term also can factorize, but okay, let's do it later. So t minus t cubed e minus t minus 6t squared. Okay, I mean a lot of the people, student, what should be 0? Where should be 0? Oh, sorry. So differentiate this one. Okay, a lot of students maybe say we can stop it here. Okay, I don't know, but my teacher tells me that it's always better to factorize it. Who is my teacher? Long time ago, my secondary school teacher. But I'm not sure. I don't think it's just aesthetic problem because maybe it's also useful. Easy is simply more simplified if you factorize it. Okay. Mistake I mean I prefer to factorize it because factorization will make it seem simpler. Step. So we get p squared t minus t minus 6 squared. Okay. Okay. So this is one of the example how to use this formula. If you want, you can try out other stuff. Okay, let's do. No. Finish this section first. Okay. Wait. Watch too much TikTok. Okay. So show that if the length of your space curve is constant, okay, then R prime T is perpendicular to RT. Does this count as a proof question or not? Yes. I don't know why they put this example, but maybe you need to learn. Okay. I don't know. So what to do? So how to do? So let's determine what you need to do first. Okay. You want to show that R prime T is perpendicular to RT. So what does this mean? What does this mean? What, not times? Yes, dot. Okay, there's different kind of time here. Okay, we have dot product, cross product, normal multiplication, maybe. Okay, so you need to differentiate what's the product you need. So we need a dot product of two of them equal to 0. So how to show this? Yeah, how to show this? Want to show. To show. I want to show. This is our frequently used short form. So I want to show. Okay, I want to show this. So what to do? So you have information. You only have one information. So let's just start from there. Okay, let's just start from there. We got SP is suppose. Suppose. The length of our space curve is constant. Okay. So we only can start from here. So what's the definition of the length? Square root of the dot product itself is equal to C. Or in other words, we have RT dot RT equals to C squared. Okay, we got this. We got this one. We want to prove this. So any idea? Any idea? Product rule. So how to product rule? What's the bridge between prime and non-prime here? Differentiation, no? Okay, so you differentiate both sides, right? You differentiate both sides. So you differentiate both sides. Can I differentiate a number or not? So how to differentiate a number then? Constant function. Okay, so we see it as a constant function. Okay, so do you know how to differentiate dot product? We got formula, right? It somehow looks like the product rule. So we got a product rule on the dot product. If you can't remember, please look back to the table, and then how to memorize it. You got a similar product rule on dot product as well. What's the right hand side? 0. Good. So R theta R prime times R, is it equal to R times R prime? Yes, right. Okay, so there are 2 R prime times 0. So what does this imply? What's equal to 0? Not yet, not yet, not yet. Now I got 2 times this dot product equals 0, right? So what's next? Okay, you can bring the 2 to the other side or divide both sides by 2, and then you get what you want. Let's design. Okay. Is it hard? Proof question? No. Change your mind already. Huh? Okay, so I mean, okay. Okay, so so what does this, okay, let's think about this statement again. Okay, we prove that it's true. So what does this statement say? If your space curve have constant radius, the tangent is always perpendicular to your curve. Okay, so can you think of any example here? Okay, sphere, right? Sphere, right? So what's sphere? S squared plus y squared equals to 1. Right, this one. Because what is the space? What's the space curve for this? Cos theta, cos t, and sin t. Okay. So the length is, in particular, the length is what? Hey. Circumference. What? Length of this space curve. 2 pi r. Okay, maybe I should stick with t from 0 to 2 pi. Okay. So the c is 2 pi r. So in this example, in this statement, takes what? So let me draw this circle. Okay. So if you draw this, so you on the point you got the direction. Okay, and then your tangent r prime. Am I doing something stupid or not? Yeah, I think I am a bit stupid. So so let me draw some more stuff. Okay. We got a point here, right? So let me put here point. Okay, so this is the direction of our point on the circle. Okay, make sense? Okay, but our tangent is going somewhere like perpendicular to this point. So this is the tangent. Okay, then we show that this tangent is always perpendicular. Okay. So far, okay. Yeah. Okay. Yeah. So also you can do it on 3D. Not that we are not talking about sphere. We are talking about curve lying on this sphere. 3, 2, 1. Okay. 了解啊。One more or one page, one page. One page, huh? Okay. After this, then next we go to art length. Okay. So life wouldn't be complete if you do differentiation without integration. Okay, so we will do integration now. Okay. Wait. Okay. So integrate. So how you integrate a vector function? You similar to derivative. You integrate every component function. Okay. You also integrate every component function. So let's do what? Let's do this one. Okay, let's copy this question down. Okay, after this example, we will take a break. Okay, let's do this. Okay, so we got a vector function. We want to integrate it. To integrate, we just integrate component by component. Okay, so integrate component by component. Which one? The differentiation, huh? Yeah, differentiation. I think just now we touched on maybe just skip it. So we integrate. These are kind of revision, yeah, revision. But it's a three-dimensional revision. Okay, so integrate t squared plus t. So you get 3 t cubed over 3 plus t squared over 2. Integrate from 0 to 1. I plus. Integrate e minus et, you get minus 2 t. Integrate from 0 to 1. What do you get? You get 5 over 6 over 6i plus this 1 minus e over minus 1, which is 1 over e, and j minus 2. Okay, good. Okay. So what's the meaning of this integration? I don't know. I don't say. Okay, let's take a break. Let's take a break. Later we will talk more. Take a break. Hello. Okay, we will come back at 1022. 1022. 1022.
Yeah. 这我要做 integration by part 是
但是我这个题目是问 dt 哎，不是问 integration。
dt 啊，
可是你要做这个的话是另外一个 question， 你要做也可以，那没问题。
这样子，如果是 integration 的，如果是
如果是我觉得要
这样子，我这样子
要
过后，
Yeah.
我这个就乘一个，这个乘这个就一个，这个乘这个就一个，过后
That's
就
right，
加是，我没有理解，
没有错，
这个这样子，这个是
dt 啊，所以我不要做
dt，
又是重复做的，刚才那个东西
哦，这个也是找这个的 derivative
啊，
那不是多少倍？
对啊，就是刚才说，不知道是一样的题目嘛？一样题目。
这不类似哦。
哦，它题目跑掉，它题目跑掉哦。它另外一个版本是先做了，这个是先加了再做，但是我把它搬过来做的。对，
会累吗？
累，
要死气了我！
这样子
今早上8点我讲这一期差一点要来了。
这个我做
你去
integration，
找哦。
这个 integration by part 不是？
对呀，对。
哎呀，
我醒来那瞬间讲，哎，算了，今天不要来了啦。
这是今天的，
没有今天的床啊，
船这不是？
都是对。
这个为什么要带2/2？就是把这
哦，
个，
我带它甚至牌，因为我们要 check 这个 point 吗？
对
这个 point 是什么时间？
其实我用哪一个 point 都可以，是。
因为
没有啊，我要这个 point，你怎么要用钱？
我用哪一个哪
你
一个？
一定找到拍是 t over 2的。
我也可以用等于0，也可以换等于1，不是？
对呀，不行。
用派我
没有
哦，J 等于 T 呀。
啊！我要找 t，我要找 t，
J 等于 T。
对，这等于 t。我要
哦，
找 t， 这个东西等于0的时候，是不是 t 等于0？啊，
哦，直接你直接把那个这样的，
我就讲直接，我刚才就讲新他们等于，我就直接看那个就好了，我看这就好，我就不要再看其他的。
我就以为你随便拿一个。
没有，我刚才有讲。
没给的话，没给的话，那可以随便拿。
什么？
就是如果要是没给 T 等于，
那你就没法做，他肯定会给你个 T 的，
一定会给吗？
也可以自己找，因为
可以自己算是吧
好？像你这个 x 不用放进来，这里你也是找到
但是这个有点危险，你看你这个找0等于0的话，有好几个点哦，所以你就要看一下其他的符合吗？其他符合吗？全部都符合了才可以用。
但是这个情况就很容易，因为对，但是他给你有啊，没有，我刚才传下去，在那里。
但是我希望考试出的 polynomial 被出现到 trigonometry
是什么
出的 polynomial
？polynomial
来
是要 graph。
问一点 extra 的，
问啊问啊，不是第一讲。
哎呦，这题的题啊，你会吗 ？property
不一定，看下去。
OK，这个啊，这一题啊，这个 Venn diagram 嘛，如果是你，你会讲话，你还记得的吗？什么叫
mutually exclusive 就是还没有遇到哦，这样分开咯。independent 我就不懂了。
independent 两个交叉了，两个圈圈这样中间有，
周末它一起交叉了又 independent 呢？
没有 independent 是说它中间会有一个
有 intersection
啊，
然后为什么 intersection 又 independent？
解释
老实讲啊，
我先上网找的，真是这样写的。
为什么 intersection 代表？
因为 intersection 不代表它有 connect， 它不
哦，它可以 intersect 或不 intersect，那个 intersection 可以是 empty 的。
不知道。
OK， 好，可以继续。然后
所以好像那个圆圈是你会讲话
，3个是不是
？3个。
所以1跟3一定是分开，但是1跟2可以合在一起。
应该讲要合在一起的，
可以，不是讲应该要合，它是可以合或不合，但是我们就把它画合所以
如果没有画合在一起，
因为你不合的意思说它肯定不合的，合在一起是它可以合或不合。那个 intersection 可能是 MD，
我找到是这样。
我明白了，我相信你，我明白了。呀，它可以合或不合。
你要讲
你合，
你讲话，
这样你就
3个圈
1、2合下啦，其他分开啦，
就1、3分开旁边啊。
等一下，这个有成啊。
我看到2种答案。
哦，你看到2种答案。对，看
一个这样咯，
看时间，
这样咯，这样子吗？1、1、2、1、3咯。
好，可以啊。
还有一个是这样咯。
可以啊。
可是
因为他没有给 condition on 1、2跟1、3。
可是他叫我画一个不了吗？就 Venn diagram 哦，不了我给他2个呗。那个破盖老师不会讲。
没有，你应该要画这个，这样的话你应该要画这个。
为什么？
因为这个包含这个条件的嘛。
哦，有道理。有道理哦，有道理。
非常好吃哦，
很骂人家。
问你呢？概率论问题，
我不一定会看这个。
他们刚刚是问你概率论题吗？
啊，是。
哦，是。其实我想问他好奇，就是他伪人图的话，这个就是他这个1、2跟1、3，就是那个分类讨论，就是他们有没有交集之类的这种。
但是他们好像有一个假设是，你如果合，就是你 OK 他们
你可以把1、3求出来，求出来
啊，没有求出来，但是1、2
求出来
，1、2是可以求出来的，可以抽出来。
哦，
可以抽出来，但是你不确定1、2跟1、3，
你求出来过，它有交集啊。
因为它是
没有。1、2跟1、3你不一定有交集啊，你算又知道，因为他们就是还是有空的部分的，
就是它有分有合，可以算得出来，他已经给了。
可以，我做这我做了可以，1、2跟1、3有交集可以算出来。1、2是算
没有，你应该
但是1、2跟1、3有没有交集算不出来？
没有，你要
是那个。
哦，所以你要
对，
没有他的意思是说你去算
1、2算得出来了
啊？对，他问你看这个如果
这个算不出来，
这个不空的话，
这个算不出来，
算不出来，
算得出来，这算不出来了，这算不出来了，
不是，因为
算不出来了，你这个，你用这个算不出来了，你这个，因为还有给你这个吗？不是，对，1、2算得出来，1、2算得出来，我知道1、2我会算了。我知道这个我会算，用这个1、2我会算了，但是你1、2跟1、3交集算不出来，因为你只要1、2、8的嘛，你用这个就可以算得出来。我知道算得出来，但是你这个图的话，
你要用
你画图啊，你画图的话，哦，你这个1、2跟1、3你有没有交集？比如说1、2跟1、3是这样的，是没有交集的还是有交集的？应该是要有交集吧？为什么？不一定吧？我算过，因为我算过，就是你没有交集也是可以的，我算过，就是反正你因为。你是要把他们2个加起来，就是1加1、2，如果它是超过1的话，就是合在一起。不超过1的，我算过啊，不超过1，就是
也不一定啊，
就1并1、2加1、3是不超过1的，我算过。 就是可以不超过1的，就是
可以不超过1。
就是说他们就是
1等于8分
算过就是
13等于多少
13这里上13
？3等于9。2428
啊，这3个加起来
23，对，要多一个1/20。
但感觉还是这样子的。如果你想是不超过1，不是不超过1，应该是。
他讲其实算得出来，你要算出来，他到底真的是有空还是没有空，还是你那个大小于
有2分，我送他的。最多一点不好呗。对，最多一点，算出来。
老师，真是本来我问的答案对不对啊？这算得出来？
没有对，所以答案是这样，还有连还是没有连？
他算出来有，我算出来有连，好像是有连吧？因为我是用连的 formula，我是有用 intersect 的 formula。
不要看那边了，下一个。
还有那个 P，因为那个会有减 intersect 那个 formula，你就算到。我没有问，我过来看吧。
要是知道这几道题的分子分配，我就知道它那个答案是什么。就是我要是知道这几个小题的分子分配，我就知道它答案是什么。但是他不知道分子分配，我不知道这第2小题到底是1分还是2分。如果说第2小题是2分，那第1小题随便怎么画都可以分，只要你2点拿到就行。
管它的，它应该就是2个循环吧？
没有，你画图是画2个循环，
都画上去嘛，怕啥？
我画上去，我交都交了。
我还没交，这不是还要做？
真的什么？
对，这个题是什么？
这个非常简单。
这个题你是哪个最大？我现在是其他原因最大。
我靠，有5道题啊！我还以为就3道题吧。我靠，那666，我还以为只有3道题。
开始，
要开始这样，
我再开始这样。什么？这个你发给我。
要上课是吗？要上课。
那个，yeah, start. 跟你说 ，ready. Why you guys got what? The assignment need to hand in today or what? Why you guys so like excited with the probability? Oh. Okay. Okay, we should continue. Okay. Ready. Hey. Ready. Okay, ready? So in R3, we also can compute the arc length, okay, and curvature this time. Okay, how curved is that line? Okay, how curvy is that line? Okay, we can compute the length. Okay. So how to compute the length? Okay, so for R2, right? Remember we have this formula here. Okay, s squared plus y squared and then square root different integrate. So this is like remember last time we talked about Pythagoras theorem, okay? But the curve is not straight anymore. So we talk about dx, dy, dx, dy dt, dx dt, okay? Because the line is not straight anymore. So we talk about derivative. Then similarly in R3, you can see that we just add another coordinate in, which is dz dt. Okay. But the probability really bother you guys a lot. But okay. So okay. Hey. Rest a bit. Okay. Rest a bit. Okay. So anyone can recognize this form or not? What's this form?
square root something square. Length, okay, the dot product. Okay, so the dot product, what are you dotting with? You are dotting the tangent vector. Okay, you are dotting the tangent vector. Yeah. Okay, so maybe things very easy. So let's put into example. Okay, so put into this example here. So it tells you that it's a helix. I think we see this before already, right? Cos t, sine t, and then t. Yeah, so it's a unit circle, but increasing in the z direction. Okay, but they fix the segment from 100 to 102 pi. Okay, 100 to 102 pi. So maybe we can start draw the diagram first to give you some taste. Z, okay, 100. Okay, and then you grow as a circle, and then you stop at 102 pi. Okay, remember last time I talked about this? You got a rubber band, you snap the rubber band, and then one at the bottom, and then take the other endpoint out. Okay, so if you press this part down flat onto SY, they just form a circle. Make sense? Yeah. So now we want to find the length of this arc here. Okay, so what's the vector equation? So you need to start with the vector equation. It's given. Okay, vector equation is given. So you want to find the length. So you need to, what's the formula? Let's remind us. What's the formula? L equals to integrate A dt. Okay. So in this case, what is our t? What's our integration domain? From where to where? 0 to 2 pi. Okay. Just now there's one question. No, one question. Yeah. One question from the back just now. Can I use 1 to find my t or not? Can I use 0 to find your t or not? Can. Why not? But you need to set cos t equals to 1, sin t equals to 0. Okay. But one problem with this is cos sine are periodic. Okay. So you need to find one point that is satisfied by all three equations. But in this case here, the third coordinate is just t. Okay, so this t will straight away give you the integration domain. Okay, so you don't need to care about the first two. Okay, so how to find r prime t? Just now we already know how to find r prime t, right? So we just differentiate. If we want to differentiate a vector function, we just differentiate component by component. Okay, so first component you get what? Sine t minus sine t, right? Okay. Second component you get what? Cos t. Third component you get 1. Okay. So in the middle is what? In the middle of the norm is what? Is a vector function. In particular, it is a vector. Okay. So vector, can you compute length or not? Okay. How to compute length? Dot product. Good. Dot product. So we do dot product. Okay, do dot product. And then if you want to compute the length, you need to take the square root. Okay, so you need to take square root. You need to take square root. What's this whole thing? I think it's square root 2. Everyone see square root 2 or not? you have a trigo identity use sine square t plus cos square t, okay, plus 1, which is 1 plus 1, which is 2. Do I need to write down? Write down. So I get sine square t plus cos square t plus 1. Note that this inside here must be positive. If there is not something negative, something wrong with you. Because length must be always positive. Okay. So this is one way to check whether you do the right computation. So what do you get? You get 2 pi square root 2. Do you observe anything here? Any observation here? Huh? The length is 2 pi square root 2. So if a unit circle, what's the circumference? Yeah, I mean, okay, 2 pi r for circle. How about unit circle? Radius is 1. Is 2 pi. So 2 pi longer or 2 pi square root 2 longer? So it's not just bringing that circle up. So there's something more here. So this if you trace out that helix is longer than just a unit circle. Okay. You could imagine, right? Because it like somehow it gets stretched. Okay. So if you just take a single string and then if you want to follow the x square y square equals to 1 cylinder and then increase again, but come back to the same point, it gets stretched. Imagine, okay. Otherwise, you cannot use unit circle to come back. If you want to increase with height, you cannot never come back with the same endpoint. I mean the circle endpoint. But yeah, okay. So it means that you get stretched. So how stretched is it? Is computed by the curvature. Seems like we don't cover. Oh, we did. Okay. Okay. Next. Next. So instead of computing okay, so this not justify. Okay, so this compute this we got this arc length function. Okay, let's say we keep our endpoint running. Okay, we keep our endpoint running. Okay, we will get something called as arc length function. Okay, st depend on where we want to stop. Okay, what's the significance of this? Is you differentiate this function again, you will get exactly the length of your r prime t. Okay, you get the r prime, the length of the r prime t. So how is this useful? Yeah, how is this useful? This is for reparametrizing the helix. Okay. So you guys seen reparametrization before? What is it called last time? I forgot what it's called in calculus 1 already. Okay, but anyway, reparametrizing the helix with respect to the arc length, again, measure from 1, 0, 0. So meaning we want to parameterize this curve such that when we do integration, we know from where to where it is length 1, okay, unique length. Okay, let's do this. I'm not sure this is covered or not, but let's do this. Okay, so reparametrizing. So we want to reparameterize it as a following arc length. So what we do is we first compute the length of our tangent vector. Okay. So I think we compute this before, which is square root 2. Okay, this is the thing inside our integral. Okay, so what does it mean by reparametrization? So we need to first compute x in terms of t first. Okay, since we know the derivative of x with respect to t, so we can integrate this whole thing, bring it back to t. So that we can get a relation between x and t. Okay. So in this case, what does this reparametrizing do? So we want to reparameterize the curve with respect to the arc length. So we change the variable to x over square root 2. Okay. And then we will use this curve here. I invite you to do one experiment. So try and do integration, the same integral we did before on this curve here. Okay. Then you will see what is this curve, what's this reparameterizing doing. So I'll try experiment. So let me write down. Do the previous integral on this new parameterize. Okay, so you can see that this t here, I kind of slow it down. I divide by square root 2. Okay, I slow the time down. And then you can see what happened to the integral. Okay, any question? Yeah, do the previous integral on this new parameterized curve. So meaning you go and compute 0 to 2 pi, huh? Yeah, 2 pi of Rtx. Or what should I say? Yeah, okay, I don't want to put this down. So I'll let you think about it first. Yeah, just think about what you like to think first. Try to experiment whatever you want. Integrate with this new vector function here. Do whatever you want. Yeah, wrong also never mind. They will tell you something. Then I will try and put down what I want to put. Do whatever what you want. I do whatever I want to do. Okay, yeah, because it's like this one. When you learn, right? When you learn, you need to like explore a bit. Okay, this is just some small adventure I let you do. Yeah, explore. Even if it is wrong, that's fine. You will see something else. Okay, I let you see first. Whether you see tiger or elephant, I don't know. I let you see first. Okay. Okay, next. So what are what are we doing here? So this is the real motivation we are doing this. So it's about the motion in space and velocity and acceleration. Remember last time we talked about the orbiting sun and moon and Earth, right? So Newton created this for finding the orbit of the stars. Okay. Okay. So why we differentiate once, why we differentiate twice? Okay. So why we looking at space curve? Okay. So you can imagine you all drive car, right? Okay, your car move, okay, on the road. Okay. When you move, you trace out a space curve in the earth. Okay. If you differentiate once this curve, you get your velocity. Okay. Velocity. And then if you differentiate twice, you get the acceleration. Okay. So this is what we say. Okay. And then if you want to talk about speed, okay, speed is a scalar. Doesn't care about direction, front or back. So we just take the length of your velocity. Okay. So we don't want to talk too much. Just go and do example So now you have an object moving in a plane. Okay, you can think of a car moving. So you want to compute the velocity. What's the velocity? Prime. Good. Prime. So I think now you can pretty fast if these are prime, right? 3t squared I plus 2t. Okay. How about the speed? Put the speed. Speed is what? Speed doesn't have direction. Okay. So how to make this become a non-directed thing? You compute the length. Okay, compute the length. So compute the length. The length is the norm of velocity. Okay. Which is the inner product of R prime t. Know how to do inner product now? So you get 9t to the power 4 plus 4 to the power 2, which is t squared 9t squared plus 4 squared. Okay. Okay, let's keep continue first. Actually, we didn't finish reading this question. It is at when t equals to 1. Okay, but never mind, we continue first. Then later we substitute t in. Okay, so acceleration is what? R prime prime. Yeah, R prime prime. We should get 6ti plus 2j. Okay, so now the question asks about t equals to 1. So I need to sub t equals to 1. So what is R prime 1? Which is 3i plus 2j. Okay. What is length of R prime 1? It is 1 square plus 9 times 1 plus 4 square root. Square root. Square root 1. 13. 13. Yeah, 13. Because this is a plot. This is a multiply. R prime prime 1. Get 6i plus 2j. Okay. Okay, so note that the first part we found are vector function. Vector function. And then here is a real value function. Okay. And then here, when it's specified to 1 point, we only get vector or number. Okay. Make sense? Okay. This work for any t, so you get a vector value function or real value function, vector value function. And then when you evaluate at t equals to 1, it reduces to a vector or a number. Okay. Okay, let's continue. Very easy, right? Which one? Which one? Right, correct, right? Because velocity need direction, right? So you in vector form. Acceleration also need direction, so in vector form. Speed, no need direction, so in a scalar form. Okay? So you have to know what you are doing. Okay, next. Same question. Same question, should we skip? Skip off. Let's do something harder. So this one left as homework. Okay, let's do this. Okay, do this. So an object with, I think this will be the last, hopefully the last. Okay. An object with mass m that move in a circular path with constant angular speed. Okay, you don't care about what angular or what it's just the most important part is the speed. Okay, speed has position vector. So position vector. So you have some space curve coming out again. So now find velocity and acceleration of the object. And also find the force acting on the object. But I don't tell you what is force, right? So if I ask this, I should tell you what is force. So in this last sentence here says that force is equal to MAT. No moving. E. Why? Maybe you want me to stop already?
Yeah.
No, no. Let's do as much as we can. I doesn't like this team. Teams are online. Stuck. I think it's a Wi-Fi problem. Okay, you work out first. You work out first. Later, you try first. When I show me, I will start. You try yourself. See anything you can try out. Yeah, it's Wi-Fi problem. I cannot find it. Okay, so maybe I just use Word and then maybe I will write tomorrow. So, okay, so this question here says angular speed. Okay, why they use angular? Because you move in a circular path, so there's nothing special there. So angular there refer to circular movement. So what you have is space curve. Okay, I give up on this iPad now. So we have space curve. Okay, spatial formula A cos WT, A sin WT. So can you find velocity? R prime T. Okay, differentiate component by component. Acceleration, can you do it? A, so it's a V or R prime prime T, which is V prime T. Okay. After you get acceleration, then you can compute force. Force is equal to M times AT. So your force is just M times your acceleration. Okay, that's all what we did. We can check answer tomorrow if you want. And then we will continue 1, 2, 3, 4. Maybe one more example, two more examples, we'll finish and then we will go into infinite series. Yeah. Okay. So see you on Thursday. Okay. Good luck. Good luck on your statistics.